Hello class, so I have to film the demos separately from the screencast, and that's okay. So our main goal for this activity is to figure out what causes the biomes to exist where they exist. And in doing this, we're going to do just two little demos. So the first demo says flashlight demo, so I'm going to show you that now. So I have this tiny flashlight, it's on already. Whoa. It's not the best flashlight in that it's got like very dispersed light, and that's okay. So I'm going to try to pick just a circle of light that I'm looking at, and it might be a little bit harder for you to see. If I hold it off to the side, you see there's like a more concentrated circle of light, and that's what I'm going to be focusing on. So this circle. So I'm holding it. I'm going to measure with the Sharpie because that's an excellent way of measuring. Okay, I'm holding it just so it's this far, so from the tip of the Sharpie up to the lid, that's how far it is from the page. So I'm going to measure again just a little bit. Okay, that's about how far it is from the page. So I'm going to be tracing just that inner circle of light. And what we're looking at is how the angle of light impacts the concentration, of the light energy on the surface. It's not the best. It's hard for me to trace and hold the flashlight at the same time, but that's okay. So I'm looking at this as my initial. When I'm holding this at 90 degrees, that's the inner circle of light. Okay, so that's it. It takes up about this area. Not the best circle. So then I'm going to hold it at the same distance from the page. I'm still trying to hold it at the same distance from the page. But this time I'm going to tilt it. So I want the bottom part to be about the same distance from the page. Okay, let's see. I got to measure and try and hold my hand still and right, which is maybe too much for me. So I'm going to see, because I need to try and get that inner circle. So that inner circle, that bright area, so you can see that bright area right there, I have to be able to trace it on the page so we can compare the areas. So I'm just going to hold it, okay, let's say at about a 45-degree angle. And I have to hold it a little bit further back, actually, because it's taking up too much of the page and it won't fit on there. So I'm trying to look, and now I'm going to trace the brighter circle of light. And it's not going to be perfect with my one-handed drawing and all of this, but I'm trying just to get an idea of where is that light concentrated. Oh, it kind of looks like I drew an egg, actually. That was unintentional, but there we go. And this is holding it, and I'm not going to measure, I don't have a protractor, at about 45 degrees from the paper. So if we look, okay, it'd be 90 degrees would mean right upright on the paper, and then 45 would be just at an angle coming onto the paper. So I'm actually going to pause the video for just a sec and turn the light on. Okay, so we're back. So let me turn the flashlight off so I'm not wasting the battery. So this is what we're looking at. So when we hold the same flashlight, so imagine it's the exact same flashlight, it has the same batteries, the same light bulb, so it's the same amount of energy leaving the flashlight. If we hold it at the same distance, okay, the exact same distance, if we hold it at a 90-degree angle, then the light is concentrated on this area. Okay, and if we hold it at about a 45-degree angle, then the light is concentrated over this area, just in that inner bright circle of light. So the question then is, well, where's the energy more concentrated and where is it more dispersed? So as we're thinking about that, okay, remember, the same amount of energy, here the energy is over this very small area, and here the energy is over a large area. So where is the energy going to be more concentrated? So try your best. Think about it. Pause if you need to think about it. But what we find out is here, the energy is highly concentrated. Okay. And so it's the same amount of energy over a small area. So that means there's more energy per unit area. Here, when we hold the light at an angle, the energy is much less concentrated. So if we look per unit area, if I took the area of this entire oval, it would be much greater, and the amount of energy hitting each unit area of this circle would be much lower. So the energy is just much more dispersed when we hold the light at an angle. Okay, so I'm going to pause there. If you're done with the demo one, then you can pause it here as well and then go back to the notes video. And I'm going to try and get set up for the second demo.